Good evening, everyone.
Yes, sir.
Good evening, sir.
Good evening.
Good evening, sir.
Yes, ma'am. So, till which problem did we do?
Example 11, sir.
Example 11. Huh? Yeah. So, we'll start with the next one. So, example 12. Discuss the continuity of the function defined by f of x is equal to x plus 2 if x is less than 0, minus x plus 2 if x is greater than 0. And all of you, please switch on the videos. Others? Pranav. Yeah, Divya, tell me how to solve this problem. 1 minute, no, 1 minute. Before that, I repeat, I want everybody to switch on their videos. Yeah, Divya, tell me.
Sir, limit extends to
Correct?
limit extends to 0, sir.
0, but observe. Like the function is broken at 0. So what will you take? Limit extends to 0?
Minus 1. 1 minus.
0 minus.
0. Okay.
0 minus. So what function will you consider?
X plus 2.
That's right. So what will you have here? So when you substitute 0 here, what will you have? You will
2.
get 2. So this is what? This is the left limit. Similarly, limit extends to 0 plus is what? Limit extends to
minus x plus 2.
What is this going to be?
2, sir. Minus 2.
It will not be minus 2.
2, sir. Sorry.
Yeah, it will be 2. This is going to be the right limit. What is the function value? F of 0.
0 plus 2, sir.
The tricky part here is, you look at the definition of function. No? Did they give anywhere equal to 0?
No, sir.
So f of 0 we cannot define. Because when I say f of 0, had the question been like this, x less than or equal to 0, then I would have considered the point of x plus 2. Then I would have taken x plus 2 as a function. But here, which function should I take for 0? Because none of them are equal to 0. Are you able to understand what I'm saying? Look at the limit value here. Yes. So what happens is f of 0 is not known to us. Here, what is happening? Left limit is equal to the right limit, but it is the function value is not known to us. Hence, it is. What is the conclusion? It is
discontinuous.
Perfect. It is not a continuous function. It's a discontinuous function. Right? So when you say it is discontinuous, right? It is discontinuous at which point? It is discontinuous at x is equal to
0, sir.
That's right. Because x is equal to 0, the function itself is not defined. You're able to understand?
Yes, sir.
But here, what will happen is, if at all you take x plus 2 alone individually, it is continuous. If you take minus x plus 2 individually, that is also continuous in its domain. But it is discontinuous at 0 because we don't have the function value defined at that point.
Sir,
Yeah, tell me.
if it is if 0 is not defined, if it doesn't exist in the question itself, that means it discontinuous, sir.
It's not like that. Right? Here, the question, we don't know what is the function. No, in this question, like that, it is happening.
Yes, sir. That only I'm asking. If it is not mentioned, if it's
Yeah,
not,
it will be discontinuous at that. Yes, that's
Okay.
obvious. Yeah. But when you mention the discontinuity, you need to mention the point at which it would be discontinuous.
Okay, sir.
Yeah. So is that point clear?
Yes, sir.
13th. Discuss the continuity of the function given by f of x is equal to x if x is greater than or equal to 0, x square if x is less than 0. Pranav, you tell me how to do this.
So limit x tends to 0 minus will be
Okay.
x square
Very good. Very
is
good.
equal to 0.
That's right.
So limit x tends to 0 plus will be
Okay.
x is equal to 0.
That is also
So
0.
then f of 0 is also 0.
What about f of 0? But where did you substitute the 0 in x or x square?
X
X, because that is where you have equal to. So all the three are equal, hence it's a continuous.
continuous.
So if I have to draw the graph for this, right, it look in this way. Observe, no? See, this is the graph for which function?
Polynomial.
No, this one. Y is equal to
X square.
x square, right? So I would have drawn a complete u, y is equal to x square, when the value of the domain is x belongs to R. Right, but here x square is defined where? It is defined only for the values
0.
less than 0.
Yes.
Correct. See, that is how it is given. X square is less than 0. So I need to take only the left side values and I'll put it till here. And I'll put it till here. Right. And from x is equal to 0, which function is taking over?
The linear x function.
So here I'll use another color C. So this is how the graph for this function will look like. Are you able to understand what I'm saying? So this is y is equal to x square and this is y is equal to x. So this is a combined graph whenever the function is broken into two parts. Clear? So you can make a note of this. If there is any doubt, please get it clarified. Yeah. Shall I proceed?
Yes, sir.
Yes, sir.
Yes. So this is how they have given it. See, no? This is how the graph looks like. Next. This one I'll solve it. Show that every polynomial function is continuous. I think I have already stated this. You can make a note of this also. All polynomial functions are by default continuous. See, Sai Kalyan, you asked me a doubt. No. if you look at all the problems that we have done till now, all are polynomial functions only. X plus 2 minus x plus 2, everything is a polynomial function. So polynomial function by default is going to be continuous. So where do we, whenever they say discuss the continuity of the function, no, if at all the function is broken, our only job is to describe the continuity of the function at the point where the function is broken. At all other points, by default, those functions will be continuous. So by next time onwards, right, if at all a question comes in MCQ, you can look at it and tell. For example, if I look at this problem, if I look at 13th one, right, how I'm going to solve this, you wrote the steps, no, these steps are needed for the exam perspective, but suppose you want to solve the problem faster. By looking at it without even using pen and a paper, look at the function. Is X a polynomial function? Yes, it is. It's a linear polynomial. Is X square a polynomial function? Yes, it's a second degree polynomial, right? So by default, they both will be continuous only. X is continuous, X square is continuous. So when can they become overall continuous function? Only when you check that X is equal to 0. So directly substitute the value 0 in both the functions and check. So if you substitute 0 here, I'm not even using my pen and paper. Like if I substitute 0 in X, I'm going to get a 0. If I substitute 0 in X square, I'll get a 0. At X is equal to 0, what is happening? Again a 0. So hence it is continuous. Are you guys able to understand? Suppose this question comes in MCQ, you will not sit and waste this much of time. The reason being, this is the answer. Every polynomial function is a continuous function. So how to prove that? Let f of x be equal to a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus so on till an. This is the general form of a polynomial function. So what does the definition of continuity of a function tell us? Limit extends to c, f of x should be equal to f of c. Am I right? So what is limit extends to c f of x? Basically, whenever any function does not have a denominator, just substitute the limit value directly and see. So what is it going to be? A naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus so on till an. Is this not exactly equal to f of c? Makes sense. So this part I obtained by substituting the limit. If I directly take c and substitute it here, I'll get the same part. So since limit extends to c, f of x is equal to f of c, we can conclude that the polynomial function is continuous throughout its domain. And by the way, what is the domain of a polynomial function? X belongs to R, where I have considered a point C, which is a part of the domain. Is the point clear? Am I clear? Yeah?
Sir,
Tell me.
shouldn't we substitute c in the place of x?
That's what I did. Oh, here, sorry, a naught c power n, yeah. A naught c power n, this thing, yeah. No, it's the same thing, right? A naught c power n plus a1 c power n minus 1 plus so on till an. I hope it's clear. Shall I proceed?
Yes, sir.
Next, 15th one. Find all the points of discontinuity of the greatest integer function defined by f of x is equal to greatest integer of x. So we need to find all the points of discontinuity. So where is the function going to be discontinuous? When I say f of x is equal to greatest integer of x, where is the function going to be discontinuous? You remember the graph?
The
Sir, the
integer value.
integers.
at the integral points, right? So it's going to be like this and a circle, like this and a circle, like this and a circle, right? At all the integer points, the function is going to be discontinuous. Okay. This one, I want everybody to concentrate. Listen to this carefully. What is the domain of this function x belongs to? What is the domain of this function? Like, what are the values that you are? Now, what I'll do is, I'll consider c, which is an integer. I'll consider c, which is an integer. Observe this. Limit x tends to c minus greatest integer of x. Concentrate, okay, concentrate. This is something which is tricky. I want you all to concentrate. So this will be equal to limit. I told you the first method, you remember? When you shift from c minus, you need to change it to another variable, h tends to 0. Right? Limit h tends to 0. In the place of x, what you will substitute is, you will substitute c minus h. Makes sense? Till here, am I clear? I need a confirmation. Am I clear?
Yes.
Yes. Now tell me one thing. If I have greatest integer of 2, what is the answer going to be? 2. If I have greatest integer of 2 minus 0.91, what is the answer going to be? So what will happen to this value? It will be greatest integer of 1 point something. I'm not concerned about that something. So what would have been the greatest integer? It would have been
1.
1.
it would have been 1. Similarly, if I have greatest integer of 2 plus 0.91, what would the greatest integer be?
3.
It is 2. So why I took this example is, I took c as an integer. So limit h tends to 0. When I write c minus h, what would be the output? Is it not going to be c minus 1? Like how it happened? 2 c is 2, h is 0.91, for example. So greatest integer of 2 minus 0.91 came out to be 1. How can you relate that 1 to this 2? 2 minus 1. So similarly, can I write this as c minus 1? Similarly, limit x tends to c plus greatest integer of x is going to be equal to limit h tends to 0, greatest integer of c plus h. So what is greatest integer of c plus h?
C plus 1.
It's not c
C.
plus 1.
C.
It is c itself. It is c. Now, what is f of c here? F of c is greatest integer of c. C is an integer. Greatest integer of c is going to be c. So what is happening here? Left limit is c minus 1. Right limit is c. F of c is c. So right limit is equal to the function value, but not equal to the left limit. Hence, what kind of function is this? It is a discontinuous function. Makes sense? Yeah, see, this is how we need to show it. But if the question comes in, let's say 1 mark or something, right, in MCQ, what you can do is you can say that it is discontinuous at all the integral points, that is the integer points. Clear, guys?
Yes, sir. Yes, sir.
Good. Shall I proceed? Shall I?
Yes, sir.
Okay. Yes. So, did I explain this concept already? Algebra of continuous functions. Did I describe this? No. Okay. So, we will discuss the concept of algebra of continuous functions. Right. So, what will happen is, so in the previous class, that is in the 11th grade, after having understood the concepts of limit, we learned some algebra of limits. Right. What do you mean by algebra of limit? Basically, you have two functions. You can do multiple operations between them. F plus g, f minus g, f into g, and f divided by g. Right. So when you do these kind of operations, right, there is something that we will be able to understand about the continuity of those functions. So by now, I hope everybody understood that whenever you're discussing about the continuity of function, you're trying to check whether the limit exists at that point or not. Right. So what should happen? Basically, it's only one thing: left limit should be equal to right limit should be equal to the function value. Right. So the theorem 1 states something like this. Suppose f and g are two real functions which are continuous at any real number c. Then we can conclude that f plus g is continuous at x is equal to c, f minus g is continuous at x is equal to c, f into g is continuous at x is equal to c, and f divided by g will also be continuous at x is equal to c if g of c is not equal to 0. Okay. Am I clear with this?
Yes, sir.
Yes. So having said this, we'll do some problems. Okay. 16th one says, see all these points. No, I want you to make a note. See, I told you some important points. No, if possible, at the back of your notes, right? You're maintaining a notes for math, right? At the back of it, make a note of all the important points that I keep telling you, so that it will be a quick revision. Don't write it in the same page, because before exam, if at all you forget, the last page will help you to recollect them faster. Is it clear? So first thing that I told you is prove that every polynomial function is continuous. That is one thing that you can have in your mind. Secondly, this is also an important result you can keep it in your mind. Every rational function is continuous. So when I say rational function, what is that comes to your mind? H of x is equal to f of x divided by g of x, where g of x is not equal to 0. And one more thing to be noted is f of x and g of x are polynomial functions. So f of x and g of x are polynomial functions. This I've told you, right? See, in your 10th grade, you would have learned about the rational numbers. I repeated, though you know the point, I'm repeating it. Listen to this. What do you mean by rational number? Integer divided by integer, where the denominator should not be equal to 0. Whereas whenever you talk about a polynomial function means, whenever you talk about a rational function is a ratio of a polynomial and a polynomial function, where the denominator polynomial function is not equal to 0. That is the point we need to make a note of. So by now you would have understood. So if I take a point C which is in the domain of R, domain of H of x, right? Then limit extends to C, f of x divided by g of x is going to be equal to f of c divided by g of c. I can confidently write it because C is a value from the domain which will definitely not generate g of c to be 0. because the function itself is defined in such a way that you can take any real number except the value of x, which will generate g of x to be 0. Am I clear with this? So f of c divided by g of c. And what is this actually? Is this not equal to h of c? So since limit extends to c, h of x is equal to h of c, every rational function is going to be continuous function. This is the reason. Shall I proceed?
Sir.
Yeah. Discuss the continuity of sin x. So discuss the continuity of sin x. So the function is y is equal to sin x. And what is going to be the domain? X belongs to R. So what can you say? Limit extends to c, f of x, that is sin x, is equal to sin c. And what is f of c? F of c is also sin c. So since limit extends to c, sin x is equal to sin c, we can conclude that the given function is continuous at every point. So sin x is a continuous function in its domain. Sin x is a continuous function in its domain.
சார்
Tell me.
சார் புக்ல வந்து இது எப்படி சார் போட்டிருக்காங்க புக்ல சொல்யூஷன்
இதுவா? They've used the left limit and right limit. They've used the left limit and right limit concept.
ஓகே
Okay. You want me to explain it? I'll do it.
எஸ் சார்
See, if you take the left limit, okay, limit extends to, let me take a number c with a minus. Limit extends to c minus. I'll take sin x. So whenever you write like this, right, the detailed way of solving this is you need to shift this x to h. Limit h tends to 0. What should I write? Sin of I'll write it as c minus h. Okay, the c minus and h should be combined. You write it as sin of c minus h. So limit h tends to 0. What is sin of a minus b? Sin a cos b minus cos a sin b. So if you substitute h tends to 0 here, it will be sin c into cos 0 minus cos c into sin 0. What will you get? Sin 0 is a 0. Sin c is sin c only. What is cos 0? It is 1. Okay, it will come out to be sin c. So what is this value? This is the left limit. Now, Kalpagesh, you try. How will you write the right limit? Just observe, no, you will understand. If you are able to do this conversion, you have mastered it. Okay. So what should I write? Limit extends to C. What change should I?
Plus.
C plus. Sin x is sin x only. So limit h tends to 0. What should I write? Sin of?
Sin of C plus H.
That's it. So sin of C plus h means what will you get? It is going to be sin C cos h plus cos C.
Cos C sin H.
So this is limit h tends to 0. Now substitute the limit. So what will you get? Sin C into cos 0 plus
The cos
cos.
C into sin 0.
That's it. So sin 0 is a 0. Cos 0 is 1. So what will you get? You will get a sin C.
Sin C.
That's it.
Okay.
What is it? So left limit is sin C, right limit is sin C. What is f of C? That is also sin C. So left limit is equal to right limit is equal to function value. That's what they have done. That. Okay. Let me know once you're done copying.
So completed.
Okay. Yeah. So 18th one. Prove that the function defined by f of x is equal to tan x is a continuous function. It's again simple, okay? So f of x is tan x, x belongs to R except 2n plus 1 into pi by 2. Right? So when you take a point C, right, you take the point C in the domain of the function. So when you take that C, you will not take pi by 2 at all. Or you will not take 2n plus 1 pi by 2. Am I right? Guys, are you able to understand or not? So when you take the point C, that C will belong to any real number except 2n plus 1 into pi by 2. Now we need to discuss the continuity of that function. So for that, what I'll do is I'll take limit extends to C minus tan x. Are you here?
Sir.
Yeah, can you tell me how to convert those steps? Just now I solved a problem.
Sir,
No?
limit h tends to 0.
Very good.
Tan of x plus c, sir.
Correct. Appara.
Minus c, sir.
Come again. Tan of
x plus h, sir.
plus minus is there. No, C minus is there. No. See what I did here. If it is C minus, I wrote C minus H. 1 minute. My net is a little slow. 1 minute. Yeah. See, when it is C minus here, I wrote C minus H. No. Wherever X is there, you will replace it with C minus H.
Okay, sir.
Okay. So what should the value
C minus
here
h,
be?
sir.
That's it. So tan of C minus H. See, I don't know how the solution in the textbook is given. I'm showing you the detailed analysis of left limit, right limit, and function value. Okay. So this is limit h tends to 0. Tan of C minus H. Tan of A minus B is tan A minus tan B by what is it? 1 plus
Plus tan A, tan B.
tan A tan B. So what should I do? I should substitute the limit h tends to 0. If I substitute h tends to 0 here, I'll get tan c minus tan 0 divided by 1 plus tan c into tan 0. Am I right? So tan 0 is 0. Tan c into tan 0 is 0. So what am I left out with? I'm left out with tan c. Am I clear? So this is what limit? This is the left limit. So what about the right limit? So what about the right limit? Limit x tends to c plus, I'll have tan x is equal to, hurry and complete it. Limit h tends to 0, tan of,
Sir, tan of c plus h, sir.
okay, now you tell me what is the
Then
formula?
limit h tends to 0, tan c plus tan h by 1 minus tan c tan h, sir. Will be tan c, sir.
1 minus tan c tan h. Then what will you do? You will take that h tends to
Yes,
0 and
sir.
substitute it.
Yes, sir.
Then what will you have? Tell me.
Tan c, sir.
Tan c minus, give me the detailed step. Tan c minus,
Tan c plus tan
oh
0,
sorry,
sir.
tan c plus tan 0
By 1 minus
divided
tan
by,
c into tan 0, sir.
correct.
So it will
So
be tan
tan
c,
0
sir.
eliminated. Yes, that is going to be tan c. Then this is going to be the right limit.
Continuous.
Then what about the function value? F of c is going to be equal to tan c. So what can you conclude? Left limit is equal to the right limit is equal to the function value. Hence, it is continuous. I hope you're able to get a grip of how to use this left limit and right limit.
Yes, sir.
Yes. Shall I proceed?
1 minute.
Yeah, please make a note. Now, can I proceed?
Sir.
Okay. Now listen. So I don't, they have done so much. See, this is one way of doing, and you know, another way of solving the problem is using the properties that we discussed, the algebra of functions we discussed. No, see, if I take tan x can be written as sin x divided by cos x. So when you have a function h of x is equal to f of x divided by g of x, where g of x is not equal to 0. So here, what is g of x cos x? Where will cos x be equal to 0? At all odd multiples of pi 2. See, whenever you substitute, whenever you take cos of some odd multiple of pi by 2, like pi by 2, 3 pi by 2, 5 pi by 2, cos will generate a 0. But if you observe the domain of tan, what is eliminated from the domain itself? Eliminate plus 1 into pi by 2. Right, to eliminate 1 plus 1, the part of the domain itself, what can you conclude? Sin x is continuous and cos x is continuous. When sin x and cos x both are continuous in the domain of the given function, can I conclude that tan x is also continuous according to the algebra? Guys, am I making sense? Like, are you able to understand what I'm trying to say? So I told you the 4 properties, no? F plus g, f minus g, f into g, and f divided by g. those functions will be continuous if f and g are individually continuous at C. So in the domain of tan x, x is equal to pi by 2 or odd multiples of pi by 2 is eliminated. Hence, sin x is individually a continuous function. Cos x is individually a continuous function. So continuous function divided by continuous function is overall going to be a continuous function. Am I right? Makes sense. I hope it is clear. Yeah.
Yes, sir.
Can you please tell me yes or no? Not able to hear.
Yes, sir.
Perfect. So next, see, that was theorem 1. That was theorem 1. Now the next thing is, if at all I have two functions, right? If at all I have two functions f and g, which are real valued functions, such that f circle g is defined at C. F circle g is a composition of those two functions, right? If g is a continuous function at C and f is a continuous function at g of C, I repeat it. I have two functions. What are they? F and g, and I'm performing an operation between them, which is called as f circle g. And that f circle g is what it is defined at C. When I say it is defined at C, then C is a part of the domain of f circle g. Now, what is happening is, one observation that we are able to do is g is continuous at C and f is continuous at where? F is continuous at, look at the statement, f is continuous at g of C. Then what can you conclude? Then you can say that the overall composite function is continuous at the required point C. Am I clear with what I am saying? Are you able to understand? So how you will use is, if at all you have this example 19, if you observe, right, f of x is equal to, I have sine x square. Let me call this as, instead of f of x, let me call it as h of x, for instance. If I take f of x is equal to sine x, if I take g of x is equal to x square, right, then what is f of g of x going to be equal to? Right, then what is f of g of x going to be equal to?
Sir, your voice is not audible, sir.
Yeah. So by now, I am assuming that everybody would have understood that sine x square is a composite function. Yes or no? Give me that confirmation at least.
Yes, sir.
You know, right? Okay. So how is that composite function of sine x square formed? By the composition of two functions. What are they? Trigonometric function sine x and the algebraic function, that is a polynomial function x square. Correct? Now, what did theorem 2 tell us? If you have a composite function which is defined at C, if you observe, what is the domain of sine x? X belongs to R. What is the domain of x square? X belongs to R. So both the functions are defined at R. So f circle g, that is sine of x square, will also be defined in R. Correct? Sine of x square is also defined in R. When that is the case, if f of x is continuous at C, is sine x a continuous function? Is sine x a continuous function? We proved it here. Huh? Discuss the continuity of sine x. Yes, it's a continuous function. Is x square a continuous function? Where is it? Yeah. Is x square a continuous function? X square is a polynomial function. X square, is it a continuous function? Yes. So individually, they both are continuous functions. So what should happen to the composition? It should be a continuous function. That's all you need to do. So in these kind of problems, what they are expecting is, see, suppose they can ask you this question in assertion reason. I'm not sure how many of you know the new news that they have increased the number of competency based question to 50%. Last year you had 40%. No, this MCQs, assertion reason based and case study based, they were for 40%. Now they have increased this year to 50%. That is the reason I'm stressing, though it is math subject, I'm stressing this much on your theory part. I don't want you to lose even that 1 mark. I hope you are able to understand. This question, they can put it in assertion reason saying that sine of x square is a continuous function. That's the assertion. The reason they will give is sine x is a continuous function at x is equal to c, x square is a continuous function at g of c, and f circle g, that is sine x square, is continuous at x is equal to c. Is that reason right? Yes, it is right, because that is the theorem that we have understood. You're able to understand. If you don't know the meaning of it, you lose marks there. You will not know which one to choose. Clear? So please be careful with this part. So that's what I'll read out the solution. The function f may be thought as a composition of G circle H, where G of x, I took f of x, they took G of x. That's the only difference. Where G of x, they took it to be sin x, H of x, they took it to be x square. Since G and H are continuous functions, then by theorem 2, what can you conclude? G circle H as an overall function is a continuous function. Make sense? So this one will be slightly tough. It will take some time. 1 minute. NCERT PDF. Yeah. See. Yeah. In this one, you have this example 31. Tell me, what about this? Show that the function defined by f of x is equal to cos of x square is a continuous function. So how will you write it? Cos x square is formed because of which two functions? Cos x and
X
square.
so cos x and x square both are individually continuous function in the domain of R. Hence, cos x square will be a continuous function. Accepted? Right. Similarly, 32nd, if you see, show that the function defined by mod of cos x is a continuous function. See, how is mod of cos x formed?
cos x and mod x.
So which one will come first?
Mod x.
Yes. So mod x is there, then you have cos x. Tell me one thing. Is mod x a continuous? So the composition of these two things will be mod of cos x. Is mod x a continuous function? See, by now you should have known. Is mod x a continuous function?
Yes.
Yes, it is. What about cos x?
Yes.
So mod of cos x will also be a continuous function. Okay. Similarly, 33rd, tell me. They told examine. They told examine sine of mod x. You can solve it in your mind itself. So sine of mod x is a composition of sin x and
Mod x.
Mod x.
sin x and mod x. So sin x, is it a continuous function?
Yes, sir.
Yes, sir.
Mod x is a
Continuous one.
Continue.
Yes, sir. Continuous.
sine of mod x will also be a continuous function.
Continuous.
That's it. So this is how you use theorem number 2. Clear? So I hope it is simple, right? So only thing is we need to solve these problems, but as I told you, right? The exercise problems, I have already solved it. And you have the solutions already uploaded in the app also. So I want you to try it individually, try it on your own. If at all you have a doubt, please have a look at the solutions part. Examples I have already solved, right? And these problems is already there in the pre-recorded version. So try it on your own. And if you have any doubt, you're not able to understand the solution from there, you can reach out to me. Is that point clear? So in the next class, I'll be starting differentiability. I've not yet started differentiability, right? Differentiability, and then we'll go to the derivatives. So next is again a slight theory. Differentiability is a slight theory. Then we have the derivatives of composite functions and everything that will lead you to the concept of chain rule. From there, it is again simple. From there, it is purely going to be formula based, and you'll solve more of problems. Till now, we were discussing more theory, right? We'll start focusing on more problems. Is that point clear? So any other doubt?
Sir. No, sir.
No, sir.
Okay. So with this, we'll wind up for today. The next class I'll discuss.
Thank you, sir.
Thank you, sir.
Thank you.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yeah.